Welcome to solverfy.
We know that velocity equals the square root of the gravitational constant times the mass divided by r, the distance between the two objects. And we know that this is equal to pi r divided by t for any object in uniform circular motion. So solving for mass, we get that mass is equaling 4 pi squared r cubed divided by gt squared. Now, to find the mass of for part A, find the mass of Jupiter from the information known from Io. So Io being one of Jupiter's moons, we'll be using that information. So here, for part A, it'll be 4 pi squared times the distance between the center of Jupiter to the center of Io. So that'd be 4.22 times 10 to the 8th meters cubed, and then divided by the gravitational constant, 6.67 times 10 to the negative 11th, and then times the period, so 1.77 days, times 86,400 seconds per day, quantity squared. And so we find that the mass of Jupiter is going to be 1.90 times 10 to the 27th kilograms. And again, this will be based on information from Io. Part B is asking to do the exact same thing, however, just from information from all other three of the moons that Jupiter, well, three of Jupiter's moons. Jupiter has many moons. So Io, Europa, Ganymede, and Callisto. And so here we'll say Europa. So this would be equal to, again, 4 pi squared times the distance between the center of Jupiter and Europa, so 6.71 times 10 to the 8th meters cubed, and then 6.67 times 10 to the negative 11th times the period of Europa, 3.55 days, times 86,400 seconds per day, quantity squared. And this is equaling, again, 1.90 times 10 to the 27th kilograms. Second part, we'll find the mass of Jupiter using information from Ganymede. And this is equaling, again, 4 pi squared over g. I'm not going to write g again. And it will simply be the distance between Jupiter, the center of Jupiter, and the center of Ganymede. So that'd be 1.7 times 10 to the 9th meters. This will be cubed, and then divided by the period of Ganymede, 7.16 days, times 86,400 seconds per day. And this is giving us 1.89 times 10 to the 27th kilograms. And then lastly, the mass of Jupiter based on information from Callisto. This is equaling, again, 4 pi squared over g times the distance between the center of Jupiter and the center of Callisto. So this will be 1.883 times 10 to the 9th meters cubed. And then the period of Callisto would be 16.7 days times 86,400 seconds per day. Squared, and this is equaling 1.90 times 10 to the 27th kilograms. And so the question is asking us, are the results consistent? Yes, the results are consistent, even Ganymede being one digit off. Although this is significant, although it's a lot of kilograms, that's a large amount of mass. When dealing with planets, it's actually very accurate. So here, the results are consistent, and especially when we're simply using Newton's laws. We're not using any, of course, computer software to calculate the mass. So given that we're using only algebra, these figures are very consistent. That is the end of the solution. Thank you for watching.